thought we would do some Algebra 2 exam review outdoors today. We're going to do a couple of videos this week, probably 4 parts, and today we'll be looking at working with different expressions. So we learned a handful of different things over the year. Let's get started. First thing, want to find the inverse of a function. So if we want to find an inverse of a function, kind of quick and dirty way to do that is to swap x and y and solve for y. And so if we have an example here, f of x equals 3x plus 5, I'd first write it in y equals form. So y equals 3x plus 5. And then swap x and y. And so that looks like this. X equals 3y plus 5. And then we have to think about what sort of moves will get y alone. And so I want to subtract the 5 from both sides. And then multiply both sides by 1/3, or divide by 3, it should be the same. And so if you multiply both sides by 1/3, you could distribute this or just leave it in this factored form if you'd want. And now we've got y alone. And so our final answer, kind of packaged properly, we use the raised to the -1 sort of symbol to indicate inverse. And so we would write it like this. F inverse of x is 1/3 of x minus 5. The idea behind inverses is if we were to pick a number like 4 and plug it in here, 3 times 4 is 12, plus 5 gives me 17. And the idea behind the inverse is if I take in this formula and plug in 17, it should give me the 4 that we started off with. So 17 minus 5 is 12, and 1/3 of 12 is indeed 4. Look at one more example of this, perhaps just a little more complicated. So here is a of x, and it's equal to 1/2 of x minus 8 cubed plus 4. And again, kind of first step, put it in y equals form. And then we'll swap the x and the y. It gives me this equation. And my goal is going to be to try to get y alone. And so I'm going to do that in multiple parts. I'm going to try to get this chunk cubed alone first by getting rid of the 4 and the 1/2. And then to undo powers, we raise 2 roots. And so in this case, we'll cube root both sides. So let's see that. First thing, let's get rid of that 4 by subtracting it from both sides. And then to undo the 1/2, I'm going to suggest multiplying by 2. Notice over here, 2 times x and 2 times 4 produces what you'd expect, I think, 2x minus 8. Over here, that 1/2 and the times 2 gives us one group of y minus 8 cubes, and so you don't distribute that through or anything. Anyway, now I've got chunk cubed, and so it's time to take the cubed root of both sides. And so if I do that, I've got cubed root of 2x minus 8. There'd be a radical all the way across there. I didn't take the time to fancy type this one. And now to continue to get y alone, I got to get rid of the minus 8 by adding 8 to both sides. So careful over here. The 8 that I added is not part of this cubed root, and so it does not cancel out this minus 8 that's over there. That's all still part of my answer. And basically we're done. We got y alone, and so we'll write this as a inverse of x equals cubed root of 2x minus 8 plus 8. So that's finding inverses. Another skill that we've learned is probably my least favorite skill. I don't like using simplest radical form, but it's something that you're often asked to do. And so a basic idea for doing that, I suggest you write the prime factorization of whatever is underneath the radical, and then pull things out in pairs or in groups of 3 or groups of 4, depending on what sort of radical you're trying to undo. So here's an equation, or an expression. We've got cubed root of 3,000 x to the 8th, y to the 5th. If I want to put that in simplest radical form, first thing I'm going to do is break 3,000 up into its primes. And so I know that's 3 times 1,000, and 1,000 is 2 times 500, which is 2 times 250, which is, it took a while. So here are all the different factors that it had. 2 times 2 times 2 times 5 times 5 times 5 times the 3. X to the 8th is a bunch of x's. Y to the 5th is a bunch of y's. And this being a cubed root problem, I'm going to try to find groups of 3, because cube root of 2 times 2 times 2 would be 8. Cube root of 8 would be a 2, and I could pull that out. Here's another group of 3 5s. Here's a couple groups of 3 x's. Looks like I can pull 2 of them out. And there's one group of 3 y's. And so when you start pulling everything out, I had a group of 3 2's, a group of 3 5's, 2 of the groups of x's, and one group of 3 y's. And what was left under the radical is important. That's still a 3 underneath. There were 2 extra x's that couldn't be grouped up, and 2 extra y's that couldn't be grouped up. And final answer then is to take everything on the outside and multiply it together, and take everything on the inside and multiply it together. And so that should be 10 x squared y on the outside, and 3 x squared y squareds underneath the radical still. So that's simplest radical form. The idea is what's under the radical is as simple, as small as it can be. One quick variation in that, if there is a fraction, you can't have a fraction under a radical, and you can't have a radical under a fraction. And so basic idea with that, kind of the same steps, but at some point you have to multiply the top and the bottom of the expression by the same thing. So here's an example. I've got the square root of 1 over 20. And so no good because you can't have the fraction under the radical. I'm going to start by taking the square root of the top and the bottom. And then I will pull the prime factorization. So 1 is just itself, but 20 is 2 times 2 times 5. And if I start to pull things out in pairs, on the bottom, I've got a pair of 2's, but I only have a single 5, and that's a problem. And so I need to have another 5 factor on the bottom to make sure that the bottom is clean. The top usually ends up with a radical on top, but the bottom cannot have one. And so to make this come out nicely, I need another factor of square root 5 on the bottom. And so I will multiply the top and the bottom by a square root of 5 over 5. So if I do that, on top now I've got square root of 5, because 1 times 5 is just 5. And on the bottom I've got this nice expression, 2 times 2 and 5 times 5, and there's a pair in each of those. And so now I can pull out a pair of 2 and a 5, and I'll end up with 2 times 5 and nothing under the radical anymore. And on top, there's nothing I can pull out, so that's going to just stay as root 5. And final answer would be to multiply that 2 times 5 and get a 10. So root 5 over 10 is simplest radical form. So one last expression, a bunch of things, and this may feel kind of random, but I grouped things together this way on purpose. So evaluating logarithms. So you've got log base 3 of 81. And the idea behind a logarithm is it's a way of describing exponents. And so this is asking what exponent is required to bring 3 up to 81. Or in other words, 3 to the what is 81. And a lot of times, if it's a nice one, if it's a worksheet that's made to come out cleanly, you could probably reason this out in your head. 3 times 1, or 3 times 3 is 9. 3 times 3 times 3 is 27. 3 times 3 times 3 times 3, it's 4 3's, would be 81. And so there's our answer, 81. Over here, however, this one doesn't come out nicely. 4 to the what is 100. 4 squared is 16. 4 cubed is 64. 4 to the 4th is 256, I think. And so this doesn't have a nice, clean exponent. It's a 3-point-something sort of number. And so in situations like this, what you'll need to do is to evaluate it using a calculator. And so if you want to evaluate it on a calculator, you have to use the change of base formula, because the calculators that you have, you'll notice there's a log button and an ln button, but this is log base 10, and this is log base e, and there isn't a log base 4 button anywhere. And so in order to evaluate this, what you have to type is log base 10 of 100 divided by log base 10 of 4. So log of the argument divided by log of the base. Notice that gives me the 3 point something number that I was expecting, 3.32. Now you could also use the natural log as long as you're consistent. So natural log of 100 divided by natural log of 4, that also gives us this 3.32 sort of number. And truthfully, you could do this first one with a calculator right away. If you didn't want to think about it, you'd have to type log of 81 divided by log of 3. And it gives you the 4 that we could get. Anyhow, there's a couple of different things that we've learned over the year about evaluating expressions and simplifying things. Come back for the next video when we look at lots of different types of graphs. So, hope you have a good rest of your day. Let me know if you have any questions, or if you're having trouble coming up with your own questions. I would be glad to give you something to do. Make sure that you're somehow making those questions unique to you, maybe using your phone number or house address or something like that. Hope you have a wonderful day. Bye.